Okay, okay. Interest in what?
Sir, I will go to
Go to?
space.
Oh, space. Oh, very good. All the best. Wishes to you.
Well, sir, we are live on our YouTube channel, and we have few members here in the Zoom room. So it's 7:03. So we shall start the program. Can you unshare, sir, your screen?
Okay.
Let me take you on spotlight.
Can you see, sir?
Yeah, I can see your screen, but I want you to unshare your screen for a moment. I
Okay.
want to start with the introduction part. Yes, yes. Now you are on the screen. Right. Ranjita madam is on the screen. Yeah, you know. Well, dear members and friends, namaste and very happy full moon day. I, Dr. Govind Lakhotia, welcome you all to this 20th online talk in our ongoing series on sky watching techniques organized under the banner of IAPT's National Astronomy Network of IPT, that is NASNI. Today, NASNI is envisioned as a growing community, a network of passionate educators and sky enthusiasts exploring ways to make astronomy as integral part of community. It's a space for imagination, collaboration, and shared discovery. It is worth noting that our visionary national coordinator of NASNI has brought laurels to the cause by discovering several astronomical objects in this journey. Today, we are delighted to host our 20th talk in this series on a fascinating theme, toys of the space. This session will be delivered by respected Thiru I.K. Lennon Tamil Kovan sir from Chennai, whose hands-on approach makes complex space concepts accessible and fun. Professor Ranjita Deka, Vice President of East Zone of IAPT, is also with us, who will chair this session. It is my pleasure to introduce Shri I.K. Lennon Tamil Kovan sir, who is a distinguished science communicator and educator from Tanjavur, Tamil Nadu. With a master's degree in physics and over 35 years of dedicated service, he has made remarkable contributions in the field of science, communication, and outreach in Tamil Nadu. Mr. Tamil Kovan sir is retired from Executive Director post of Tamil Nadu Science and Technology Center, which is there in Chennai, where he led numerous initiatives to popularize science among students, teachers, and the general public. His pioneering work in astronomy education, interactive exhibit design, and low cost teaching aids has greatly enriched the learning experience for countless learners. Throughout his career, he has trained hundreds of teachers and inspired thousands of students through hands-on workshops in robotics, electronics, astronomy, and even puppetry in science teaching. His innovative approach to blending creativity with pedagogy continues to influence science outreach programs across the state. Beyond his professional accomplishments, Tamil Kovan sir brings science to life through his hobbies, collecting and demonstrating science toys, performing live science experiments, and creating science based videos for his digital platform, Toying with Science on YouTube, and Lennon Tamil Kovan on Instagram channel. Please join me in welcoming this great personality today, who is a science communicator. And I request Shri I.K. Lennon sir to start the session. Over to you, sir.
Good evening to one and all. I'm happy to be present here today. And thanks for the opportunity given by all IAPT team and NASNI team. One day I came across Dr. Arvind Kulkarni. Then he only requested me to join this group and introduced to Mr. Dr. Hemant Kumar. So while we were discussing, and they asked me to give a lecture on whatever topic, but I maybe astronomy. But I felt I am interested in toys and this type of communication thing. I said I can give a talk on toys and toys in space. There's a particular reason for this, because this is the 40th anniversary year of Toys in Space experiment, supported by NASA and started way back in 1985. So they are celebrating it in a grand manner. And whatever toys you can catch hold of are tested in space. In space, you can the behavior, all the science behind it, and the physical properties, whether they apply to the toys as on Earth itself. But that doesn't happen in all the toys. Some of the toys behave in space as they behave on Earth, but on in space they behave differently. So that is the basic idea of my talk. And I have more than 300 toys collected over 30, 40 years. And tops alone, spinning tops, that alone will be around 60 to 70 tops. Everything will spin, but the method you spin them will be different. There is a pistol top. That is, you load the top inside the pistol across the barrel, and if you just trigger it, it will be pushed out and it will spin there. Just like that, we have many top, and you might be knowing this popular tippy top. So that it was inverts itself, right? And the gyroscope, that is an advanced form of this top, and that is used in nowadays in all space exploration. Previously, we used to have compasses, but these gyroscopes do all the things now. So, and the gyroscopes play a vital role right from the space to the whatever the phone you have, advanced type of phone. There's a gyroscope, accelerator, everything. So everything is tied to that. So I was fascinated by all these things, and I started collecting toys. And I have some 10 or 15 toys right now with me that I will show. And there are more than 40 toys that have been experimented in space. An interesting fact is the toys, some of the toys have been designed or given by the astronauts' children. That is the beauty of this. And the children gave the toys and they wanted to test the toys in the space. In zero gravity, but it's not zero gravity actually, it is microgravity. So another thing is the astronauts carry a small toy, plush toy, that they suspend in the roof or somewhere in the inside this launch vehicle. So as they travel, how do you know where the space zero gravity starts or microgravity starts? So what happens is at the starting of that microgravity space level, these toys just start floating in space. So that indicates from that point onwards, the space, the microgravity area starts and our zero gravity areas, because from there onward, the free fall happens. So all these have been covered in this talk. And I'm not a lecturer or a professor, so I may not be able to, may not be good in articulating everything, but I am interested in this and I'm just sharing my fascination, right? Let me share the PowerPoint. Sir, can you see the screen?
Yes, sir, it's visible now.
Okay, sir. Okay. So I welcome you all to the talk on toys in space. As I said earlier, I wish to thank Professor Hemant Kumar, Dr. Kulkarni, and all other members of NASNI, and now Dr. Govind Lakotia and Madam Rajida Deka, and this little boy, Takshay Yadav. So fifth standard, quite interested, and he has joined us. I'm very happy to see that a small boy has joined this thing. Right, let me go. See, these toys in space program started way back in 1985 in the Space Transport System 51B and 51D missions. And the first experiment was actually conducted in 1985 April, 51D. So from then onwards, it was calculated, and it now is the 25th, 40th year of this thing, toys in space. And I'm Lenin Tamil Kovan in this field. For the past 2 years, I have been the executive director, and I've been doing whatever I have not done all those days. And I wish to state that I have been playing all the years, right from my joining this office till I retired. I have been enjoying this. I never thought I have been working in a field because it was such an interesting field. So that gave me all enthusiasm and life to my career. So I have started my Instagram and YouTube also, toying with science. So whatever the toys I have, and just a month ago I started, and I'm slowly making reels and videos and playing on that. So toys in space, learning physics and microgravity. So the toys reveal the secrets of the universe, not only on Earth. It is universal. The toys action, they are very universal. And actually speaking, we know that there is no concept as zero gravity, but it is a microgravity. And this microgravity happens due to free fall around the Earth. So they are the toys are the tools for learning. So when they take this toys into space, they help scientists, engineers, and the children understand how physics works in microgravity. So for that, they tried all these experiments, and they have even carried out special projects, toys in space experiments. And this is the ISS lab, and many of the experiments have been conducted in this inside this thing. And now I have a question. Can you use a whistle, or you can sound a whistle inside this space station, right? Because the space is empty, as you all know. The answer you may give in the chat. So this is inside this space station where the science, you can see they are not sitting, they are, everybody is floating, all the materials and whatever the equipments are there, they are just floating. And everything, if you don't want them to float, you have to anchor them, right? So this toys in space was designed by NASA and the educators to take everyday toys to microgravity and record the behavior for the classroom. So after that, they recorded all these things and they made a traveling exhibition, and that was taken all over US and maybe across other countries also, and they were shared with students. So they were given some toys and they were asked to experiment with the toys on Earth here locally, and they were asked questions and they should answer all those things, right? Whatever the questions they have asked, they have to answer that. Then after that, they'll show equivalent this space videos. So what has happened in space with those same similar toys? So this thing was there, and soft toys were also flown. They served as dual roles because they were symbolic or emotional comfort because the children gave those toys. So because the astronauts were in the space station were there for more than a month or up to 6 months maximum. So they had a connectivity with the family, plus all those practical visual clues, floating weightlessness for crew and ground control, right? The big question is why toys? So this is to illustrate complex physical principles, gravity, motion, rotation, magnetism. They want to test whether they behave the same way. So it was started in way back in STS shuttle discovery 51D, pioneered by scientists and educators like Caroline Sumners. The first toy, very few toys they were taken to space. One of them was a slinky paddle ball. Paddle ball is nothing but a ball attached to a bat. So that the ball won't go away from the bat. And a small toy car, push toy car. And they tried that after that in this second session, STS 54 in 93, they took many toys. So what are the principles that were concentrated in those experiments? You have those Newton's law, because that is the basic law governing all motions. So that was extensively tested. So, and these outreach programs inspired generations of future scientists and engineers. Thousands and thousands of children were shown all these things, the STEM thing, and they benefited of that. So concepts like motion, force, rotation, fluids were shown. So what are the toys that were taken to space? It is yo-yo. So I have videos about all these things. And on Earth, if you just spin a yo-yo, the yo-yo will freely fall down. So if you just hold a thread, the yo-yo will spin down to the Earth. But in space, it won't do that. It will just float. It will not come down because the Earth is pulling it, and it will be there in the Earth. It will be coming down, and it will be going up and down because of this conversion of energy. But in space, it will just start floating and will not come down as expected and slinking. So if you place a slinky and make it walk down the stairs, it will walk here. But there it will start floating. So, and it will stretch also. That's the thing. And spinning tops. So spinning tops spin smoothly and for a longer time also. And another things, they are keep that orientation. So the whatever orientation you spin it and keep it there, they'll float, because since they are floating, they'll be continuously spinning in that only. And boomerangs, they continuously, if you throw a boomerang, it will come back to you, and is because there is air inside the cabin. So this is the clue to the question I asked. So you can just think over it. And water toys. So water toys were some balloons and bubble toys were taken there. And if you spill some water, what will happen? It will just flow down here on Earth. But in space, they'll all clump together and they'll become a ball. So once this kind of thing happened in space, some astronaut accidentally spilled water, and a big, nearly 1 foot size of water ball was floating in that, inside the space station. So you can't just tap that water or just remove the water as on Earth. You can't sponge it, because whatever tiny motion you make, that will give a push and it will start moving that water in all directions. So the water ball may scatter and it will make small bubbles. So what do you think they would have done that? How do they have eliminated that ball? So what happened is all the astronauts joined together and they started sucking the water, and the water went inside. So they drank all the water. So that had happened. And this balancing bird or tipping top, they demonstrate the center of mass in new ways, right? So same thing. Gravity, or I have given that. So there are many science experiments, and they show how the physics rules the universe, whether on Earth or in space, and they studied that in detail. And these are some of the toys taken on all those missions. So that is 1985. This Slinky, and this top. This is yo-yo. That is a energy wheel, and this is a paddle ball. So likewise they have, and this is a key wound toy. So the key wound toy, how they move there. And this is here in this second mission, this is a Jacob's ladder. So I have the Jacob's ladder. So when I was in third standard, I came across this toy. So and I was searching for this toy and I got it. So this is a boomerang, small plane, pepper planes, and this is a cup and ball, and magnets. This is a rattleback, clatter ball. And here this is magnetic balls, yo-yo, football. If you we have a video of this football. There's astronauts playing football. The ball, as on Earth, they won't take a curved path. They'll just move in a straight line. So that is a fascinating thing, and we have to do when we launch something from Earth to space or something like that. We have to do all those calculations. So that teaches that. And this is a Slinky I have, and this is a cup and ball. And this is the gyroscope, and this is one of the top, and this is on the top. This is on the top. I have a family of tops. Family of tops means one top that everything will spin. That family of the smallest one will be around 1 centimeter, and the biggest top will be around 5 to 8 centimeters. So in various sizes, I have this top, and these are available in Taiwan. One of my professors had gifted me that after seeing my collections. And these are magnetic balls. And this is a Newton cradle. So it's a rattle clacker ball. And this is a helicopter. So they spin it and they see how the disc flies. And this is the energy wheel. And this is the key wound toy, and this is a plush toy. So these toys will be hung from this roof, and these will start floating whenever the launch vehicle enters into this microgravity area. So I have given all those things. So and this is a list of things. What happened to for each toy? Behavior in space, yo-yo. So angular momentum and gravity was tested. Works differently. That is they float in space. You can try that in classroom. Gyroscope, conservation of angular momentum was tested. This same thing can be done with a bicycle wheel gyro or the gyroscope I showed you. And spinning top, the rotational motion and inertia was studied. and it spins smoothly and for a longer time comparably to Earth. So this slinky wave motion and gravity was tested. They oscillate in place, show water yo-yo ball, momentum transfer. They float. They must be thrown. So, and even a skipping rope, if you just use a skipping rope on Earth, they will hang freely, but in space they won't hang freely. So what will happen is uh, they'll just float. So if you want to skip, you have to give a force so that you can extend the rope longer and you have to skip. And another thing is, uh, as you give that motion, they'll start floating. That's the thing, and they'll hit the roof. And the paper plane aerodynamics were studied. Jump rope, and that's what I was telling. It is very hard to jump, skipping on the inside the edges. So this is a video, toys in space. So the astronauts are testing a slinky there. This is a queue on top, and these are the gyroscopes there. And these, I'm having this kind of gyroscope, and this is a slinky here, and balls. And this is a bus light here. All these toys were given by the astronauts' children. So, and this suit, Magellan suit, was given to this bear, Magellan bear, and this is now is in the Space Museum from 1998. Smoky Bear was taken about a Soyuz spacecraft. So it started floating there. And this is a Walkman. So that was taken to space for the astronauts to listen to music. And this astronaut, Thomas Jane, when he was young, he studied this book, 2001, Space Odyssey. Then when he actually, and he was interested and flew back to space later, and he was studying that book there. So inside the space station. So yo-yo in space, how it behaves. So this is it behaves like this on Earth. After that, it starts floating, so it doesn't come up. So rattle back. This I have, but I can't find it my collection. It's somewhere. Slinky I have showed, and this is spinning tops. So in foot, so you play like this in on Earth. On earth, it behaves like this. So it floats and it keeps the orientation as it was left. This is skipping rope. Building toys. They took all those materials, the Lego materials, and they tried building structures there. And because you have to build structures in space. So for that also, uh, they studied that, taking Lego toys. So what happens to a whistle in space? Can you hear the sound? So the NASA made classroom kits with all those toys, and it was distributed worldwide. So some of this, what we can learn from about Newton law, gyroscope, surface tension, balance, and inertia, etc. So there are many physics labs in our orbit. Thank you. So and this is a video which I'll share. And other things I don't have.
Well, thank you very much, sir. I
Just
have shared those videos in our group of NASNI, so all can go through those videos.
and this I have shown. Okay, sir. See, I can show this one, toys. If you are interested, I can show here. Just
Yeah, you can show, sir. We have enough time.
okay, sir. Let me show the other things. It got entangled. This is a slinky. So it falls freely here, but in space it doesn't happen like this. It starts floating. And with this, we can teach many things: wave motion, standing waves, etc. And this is the energy wheel. So you can show the potential energy conversion, potential energy, and kinetic energy conversion you can show. So in space, if you leave like this, it will not come down. It has to come down. No, it will not come down. So that's the thing there. So this is a gyroscope. So this is a gyroscope. So it can balance. So if in space, if you leave like this, it will float like this and it will keep the orientation. But here it will not happen. This is the helicopter toy. So if we just push it out, so it will spin there. So this is the Jacob's ladder. It's a beautiful toy. While I was in third standard, I came across this toy.
What's its name?
Jacob's ladder.
Okay.
JACOBS LADDER.
Jacob's ladder.
The thing is, there are two sides. So you
Yes.
can have two images. And if you see the length, is the length increasing or not?
It's not in.
Not increasing. It's an illusion. But
Yeah.
so in some of the museums, they have this thing, single block, they have made it to bigger size. That is nearly 3 to 4 feet in length and 1 feet or 1.5 feet breadth. So, and they have done this and they'll give a rope and you can pull that rope so that from the top it will just topple and come down. So, and we have two images on both the sides and one will be half of this and half of that. So, one side only it will be the same and the other side it will be interchange. Here it's just like a snake.
Yes.
This also we can easily make with all small cardboards and ribbons. So I want to show one interesting toy, but I don't know whether it was used in space. You see that it is pointing towards. Can you see?
It's not in view. Yes.
In which way it is pointing?
Pointing to your
From your side.
yeah, to my right.
To your right?
Sir, to my right.
Yes.
Okay. See, I'll just invert it. Now,
Again to my right.
it's called a right pointing arrow. It will
Right.
never point towards the left.
Okay.
What's the name, sir?
Right
It's a
pointing.
right pointing arrow.
Okay, okay.
So it is made in such a way, topologically, it is so designed so that you always see it's right pointing. But if you see a mirror image, if you keep a mirror here, and in that mirror image will be pointing left.
Yes.
But what you see is always right.
Hmm.
So it's a right pointing arrow. So this was 3D printed. It is very difficult to make by carving, but a 3D printing it is possible.
Okay.
So a topology toy. And there are many toys like this, many models like this. So you see a circular image from here. When you keep it in when you keep a mirror at the back, that will be a square or a hexagon. From here, it will be a circle. But when you place it in front of a mirror, the mirror image will be a circle or a hexagon as per the design. So topologically, it is so designed ups and downs.
So how will it behave in space?
No, no, this is not a space toy, but I
Yeah.
just wanted to show something interesting.
Okay.
Sir has collection.
And this is a cup. This is a
Cup.
holder,
Hmm?
cup, and there's a ball. You have to throw like this and catch it. But here you can do this because it will come back. But in space, it will not come, it will just float. So it will not come back. That's the problem.
मम्मी मैंने लगे से हिल रहा है पूरे दिन
Huh? Yes.
No, it was a noise.
And these are magnets, magnetic bonds. So here they stick together. In space, even if you throw them there, they'll just float, and as and when they are nearer to it, they'll attract and clump together. But here, I have all those videos, but here they just stick together. Right? This is the plush toy that floats, indicating that the zero gravity area. So this is key on. So it will start moving. It will move. And these are various stops. The way you spin differs and the design differs. That's all. You have to spin hard and it will spin there. It will keep the orientation in space. This is another toy. This is the handle there, and you have to spin it. So it will be released from this holder and it will spin. Likewise, it will come out. And here we have the tippy top. Oh, so these are some of the toys. And if you have any questions, you can ask.
I think most of the toys that you are saying, if taken to space, they are floating, no? Most of the
Yes.
toys.
Everything floats there.
Yeah.
Everything floats there, but you have to give a extra force so that if you want to move it.
Yeah. Like
And it is a free fall.
Yeah.
So they will also they will always behave in a if they move, they will always move in a straight line, not a curved path.
a straight line.
A straight line. So according to that, you have to design everything.
So while they are floating, that is also in a parallel line, straight line, horizontal line?
Right. Because it's a free fall, because it is continuously falling.
Okay.
You see that as if it is moving in a straight line.
Yeah. The yo-yo also that you showed, that also it showed it went down, but later on it didn't come up properly, no?
Yes.
That
So you
was-
have to give more force so that it retracts back. So that's why in the video, in the other part of the video, they had a big yo-yo with more mass into it, so that mass gives that inertia and it spins again.
Okay, okay. Very nice.
So they have to improvise like that, and there are also this one counter in that. So that counter counts how many spins it makes before thing, and you have to throw it long also. Short distance you cannot throw.
So the gyroscopic motion also, that
Ah.
will also, will it come down? No.
No, it will float. Everything floats. Gyroscope will float.
It will not show any motion.
It will whatever motion motion will be there, but it will float. So if you keep the orientation, so the gyroscope is kept like this upright. So it will spin there itself, in that position itself. If you tilt it to 30 degree, 40 degree, 50 degree, so it will be in that position and it will spin. So if it is kept like this, it will spin like this. If it tilt it on earth, it will not happen.
Okay, okay. Thank you, sir.
And if you see the video, I'm sharing those videos, and you can go through that. And all these videos are available in the open domain, NASA site and other sites also, ESA sites also. Nearly 40, 50 minutes video is there.
Okay. Thank you, sir.
Thank you. I'm getting disturbed while talking on Zoom because it's just audio only. Otherwise, it is a PowerPoint. So we cannot show something, we cannot do experiments. So that gives me some jittery because we are not able to deliver everything fully.
Yes, sir. Yes.
That is a drawback because otherwise you have to have a big setup with all those cameras and all focusing means, and then you can do all those demonstration effectively. Otherwise, it will be just a video show talking only. But this is a both-way communication, except that, but all those Zoom and Google Meet and all, I don't like. Because when you have teachers, I'll start usually the session with question answers only. From that onwards only, I'll just build up all those things. Then I'll keep showing materials related to the questions that have been raised and other things like that. But here, I'm not that much comfortable. Anyhow, you have given me a good opportunity. And because of this collection of toys, which I have showed to so many teachers, and many teachers have started collecting the toys. So, and students have also collected. And these toys, whenever I buy them, I have two kids. One is Dr. Aditya, postdoctorate in material science. So when they were young, I started collecting, and we used, my daughter, she's an MSc virologist. So I used to buy three pieces in each toy. Which one? So they will break it and I am holding it. Otherwise, it's my passion. That's all, sir.
Thank you very much, sir, for introducing us to this other aspect of astronomy, that by collecting toys also one can initiate their curiosity and one can understand how they behave in the microgravity conditions. We have Central President Ahluwalia, sir, with us. Sir would like to.
Good evening, sir.
Thoughts.
Namaskar.
Namaste.
Thank you. I was very happy to enjoy this very special
Thank you,
lecture.
sir. Thank you.
And I was just observing a few things. One was this, that many of your toys are typical Indian toys, made of wood.
Yes, sir.
So this is one very interesting thing, that there are lots of toys around which is part of our heritage and can be really brought into the classroom. I think
Sure, sir.
particularly in Karnataka, there are some places where these kinds of toys are built, or maybe in Kerala also there are some places where
Wonderfully toys, wonderfully toys.
yeah. Second thing which was there is that though you said that you cannot show these in the Zoom here, but we would like to really request you that you make the videos of each of these toys,
Okay, sir.
discuss whatever you want to discuss, and we will be very happy to post those on our YouTube channel. I
Okay,
think
sir.
that way it will reach a lot of other people.
Okay.
Thank you very much. You shared the collection of the videos also with us.
Okay, sir.
We have actually on our website a very special page which we call useful web links. And I think we will create links for these videos there also, so that
Okay, sir.
anybody who visits our website and reaches that page, they'll be able to view those things. And I think there are some possibilities which are coming up now when we are trying in our schools, particularly in the primary and the middle school, learn by exploration. I think those toys are fit for those kinds of explorations. That is a wonderful thing. And if you shared some catalog also with us, where you had listed the toys and what is the physics concept which is involved in it. I think that's also quite useful.
Yes, sir.
You can even write a small article for our very special magazine which we publish called Anvishika Buzz. And in that, the target is the school students.
Okay.
If you feel like writing, I hope you have written articles earlier also. Please
Yes, sir.
share with Professor Govinda. I think he will be very happy to recommend that also. He is
Okay.
one of the editors of our IEPT bulletin. So that will be great. I think these are not just toys, but they are very exploratory objects which can be used very effectively when the child is on his own, trying to, tinker with the things. These toys can be tinkering toys also for the child. Thank you very much.
Thank you, sir.
Loved the presentation.
I have been writing for children for more than 25 years, sir,
Yes, sir.
in Tamil language.
We can see your passion,
Yes,
definitely.
sir.
Thank you.
Thanks, sir. Kulkarni, sir.
Yes, Arvind sir, you can.
Arvind, sir.
It is quite exciting to see the things, and I think I'm going to invite you to Bangalore. And
Thank you, sir.
give 3-4 shows here. I would like you to come and explain. I will let you know when.
Okay,
Because
sir. Okay.
in Bangalore we have a lot many children, and I thought more number will join, because what is happening is in the newer times the child in all of us is decreasing. Otherwise, I expected at least 40, 50, 60 number. But anyway, still there are 10 children. It is not a bad thing. We need to remind ourselves that we are children first and physicists and seniors later. I think that is because people are under the weight. Anyway, thank you very much. Wonderful.
Thank you, sir. You initiated this thing, sir. Thank you very much. Yes, sir.
Ranjita ma'am, anything else to add?
And Dr. Somasegara, he says, thank you, sir. Thank you. And I have one thing, collection. It is more than 30 years, and I'm looking for it in my home. I have kept it somewhere very safely. That's the problem. So it was from somewhere in northeastern state or some Rishikesh or some place like that. I don't know. It was available at that time, but it is not available. So that is a lamp with a back frame. So there will be a small a cavity for putting oil and lighting the lamp, right? Once you light the lamp, the back frame, there'll be a God's image coming out. As the temperature increases, there'll be a mask there. So it's a metal frame. So there'll be some sort of a coating on that. So as the flame lights up and that metal frame heats up, that front image will disappear and you will see some God's face that was designed like that. Once you put out the lamp, it will slowly settle down and you will see that thing, the original frame coming. So, and I am trying to locate this. I am not able to get this, but it was from North India, somewhere northeastern states or Rishikesh or something like that. Many toys are coming from that side. And recently, one of my mentor, he sent me a video of a tortoise. So, tortoise or turtle, something like that. And when you keep it in water, so it's a hollow one. When you keep it in water, it starts spinning. And that's the beauty of that. There's a small micro hole at the top. So the explanation is when you keep it in water, due to this cold water at the bottom and the hot air at the top, the air is coming out and that makes the tortoise to spin. This is the explanation given. And this is right now available in Delhi area and it came for Deepavali. I don't know whether it is available or not. So such interesting things I have collected. I have things. This I don't have. Just for information, since you are there, you may come across that toy. Thank you for the opportunity. And it was nice talking to you, though
Thank you.
the crowd is less. Thank you very much.
Well, thank you very
Thank
much,
you, sir.
sir,
Thank you.
for
Thank you.
taking out your wonderful time and sharing your expertise on our NASNI
Thank you, sir.
platform. I request Ranjita ma'am to conclude the session.
Thank you, sir. Thank you for this wonderful talk, Toys in the Space. And since it's the 40th anniversary of Toys in Space, you have really shown us this wonderful. I mean, it was quite interesting, no? And especially our young participant, Takshay. I'm sure he must be feeling very happy about it. And there were.
Yes, ma'am.
Yes. Today I was thinking you must be really looking at all the different toys you can explore and you can share with your friends also. So the young generation will find it a very interesting topic, and this itself is really inspiring for the young generation, for the school students. They will think that this such thing, their imagination will increase. They'll think that whatever we do here on earth, they will try to think in space, what will it be its reaction? How will it behave in space? So that is the best part of this talk. And I think there were, another interesting thing was that Jacob's ladder, because this is the second time I heard that it is a toy. I never knew about it because since I am in Meghalaya, in Shillong, we had a road named after Jacob's ladder. So somehow today I was wondering why that Jacob's ladder is the name of a road uphill. We used to travel by that road very often. And so now I'm wondering why they gave the name Jacob's ladder there. So
Okay.
today I saw your toy and I'm finding it very interesting. Thank you so much for that.
Thank you, ma'am.
You said that these toys in space, they took in 3 years, no? Right? In 1980,
85, 93, 95.
and 2002 also, I think so.
2002 also. Even now they are carrying that.
Oh, even now they can. Okay.
Because it is emotionally connected because the plush toys, the teddy bear, Smokey Bear are given by the astronauts' children. So
Okay.
they are taking that and whenever a new toy comes, they are experimenting with that.
Yes.
And they want to study the behavior. And mostly now the structural part is being studied there
Okay.
because they want to build in space. So at this low gravity conditions, they want to know how the materials behave and how the structure behaves. So they are trying experiments like this.
Yeah. So, indeed, it was a very interesting and very nice. I mean, this kind of I never knew that toys also we can really, that is another point, which in space, it really can be, how it's behave, it can be studied. The behavior of the toys in space can be studied. That is really very interesting. And thank you so much for giving us this wonderful demonstration as well as talk. And I'm sure it will be helpful. And since this video will be there in our YouTube channel, people can look at it anytime, whenever they want it. And again, once again, thank you, sir, for sharing your fascination. Thank you so much.
Thank you, ma'am. Thank you. Thank you very much. Thank you, one and all.
Sir, I will send to all my friends and they will be happy.
Oh, thank you. Thank you. Thank you. Please.